My name is Detlef Overbeek. I'm a Dutch guy. I hope my English is good enough. I'll try to pronounce as good as possible. So I'm starting now. What is Free Pascal? Before all, just a short notice. I do not intend to annoy you with a repetition of ancient details. So just let's talk about the important steps in the history and then dive into the details of what we have achieved. Let's see the steps already done and our plans for Pascal, and especially Lazarus and FPC. To begin with, we are convinced that the internet will become the absolute creating and communicating factor for our future, ChatGPT or not. The internet will be, or even is, the horizon for all of us. So we concentrate on the internet in our future goals. Free Pascal is an environment for developing software on whatever OS and the internet. It is an open source Pascal compiler, and we try to let it be the best. Let's go back. In 1995, Borland announced that the DOS development for Borland, so-called Turbo Pascal, would stop with version 7. Borland came up with a Windows-only product, which later was known as Delphi, and it became the successor of the Turbo Pascal. Believe it or not, this has actually caused the creation of Free Pascal. Florian Paul Klemfel started working on his own compiler in the Turbo Pascal dialect. He created 32-bit code for the DOS extender. That was in 1989. It was a software development suite for IBM PC compatibles who supported the DOS operating system. The first version of the compiler was a by Borland Turbo Pascal compiled 16-bit DOS executable. The compiler then was able to self-compile and was actually a 32-bit executable. Now just at that time, the first contributors joined the project. Michael van Kanuyt started, and he later produced a Linux port. This was even 5 years before the Borland Kylix compiler for Linux was released. Version 1 of FPC was launched in July 2000, and after that the preparations for a first release started. The version 1 was widely used in businesses and education. The 86K CPU port was rewritten and the compiler generated stable code. The compiler ran on a number of Amiga and Unix-like operating systems. Free Pascal has now arrived at version 3.22 and soon will be updated. So far the creation of Free Pascal. Before Lazarus started, the first trial project, Megiddo, began in what now is already another century, 1998, but ended somewhere a year later in 1999. The Megiddo project was a historic attempt to develop an IDE and integrated development environment for so-called Rapid Application, short RAD, with the Free Pascal compiler. But it did not work out that well. The company crashed. While the project failed, it unfolded a lasting impact, because it facilitated the transition from Sybil to OpenSybil. Even more important is the fact that it laid the foundations for the development of Lazarus. Now 3 individuals, Cliff Baseman, Shane Miller and Michael A. Hess, began Lazarus in February 1999. Each of these 3 had tried to get involved with the Megiddo project but did not succeed. Therefore, they finally started their own project, Lazarus, out of frustration with their earlier Megiddo experience. Lazarus is an IDE, some sort of integrated software environment, as mentioned before, built in a way that it is very flexible and extensible. And of course, it's open source. Lazarus can be used with all kinds of OSs, It allows execution of one and the same codebase. That makes it an IDE which is adaptable now for the future. It can be used everywhere, and for native coding, which is unique. It feels similar to Delphi, and it can be used to create console and graphical applications, Windows services, daemons. It works with native coding, web applications and WebAssembly programs. Lazarus FPC works on the inheritable object principle. It has an object inspector that will support CSS, and of course it also supports code completion in the process. It has a cross-platform user interface framework. This is called the Lazarus Component Library, short LCL. It will get a cross-platform graphical user interface framework called Fresnel, including all standard components, which can be used by the Skia open source graphical library. Fresnel will be explicitly targeted at the end of this video and is a project under development. Graphical applications created with the LCL can be ported to another platform through recompiling or cross-compiling. For making these cross-compilations, FPC Deluxe is a very smart installer and helper for cross-compiling, nowadays maintained and constantly updated by Alfred Glanzer, alias Long Dirty Animal Alf. It does not only install it all, but makes cross-compiling for various platforms easy to do. The next member to join was Mark Wersing. He got involved with the project in August 1999. Mark was looking for a Linux Delphi. At that time Borland had not yet developed Kylix, and he was also interested in Linux in general. He joined the Lazarus project because of that. It had some hard-coded GTK menu items. GTK is a free and open source cross-platform widget toolkit for creating graphical user interfaces. Mark is still a core contributor. He's a member of the Free Pascal and Lazarus Foundation. A year after this, Matthias Gertner joined. That was in September 2000. And with Matthias as a member of the team, the project made a significant move forward. Matthias ported SynEdit and coded large parts of the coder tool and the designer. With these new additions, Lazarus began to look more like it does today. 3 years later, Matthias added the package system, and he has to add further IDE features and enhancement. Martin Friebe joined the team and started his contributions to Lazarus by cleaning up and refactoring the SynEdit coder. He has since added many new features such as SynchroEdit. Later he added multi-window views to the source editor and greatly improved the debugger. And now the debugger is really functional. Matthias and Martin helped writing the Lazarus handbook and created quite some explaining chapters. The main author was Michael van Kanait. It was his second book about Lazarus. The book is now being translated into German and will be updated in the following period. Pastu.js was created by Matthias Gertner and Michael van Kanait. Pastu.js is an open source Pascal to JavaScript transpiler. It parses Object Pascal and emits JavaScript. The work started in 2005 after learning of the Morphic project. It had a similar aim. The work resumed in 2015 and the first workable version was released in 2018. The JavaScript is currently of level ECMAScript 5 and should run in any browser or in Node.js. It's available in 5 forms: a library, a command line program, a web server, a Node.js program, and a program running in a browser. It transposes from actual Pascal source. It has no intermediate PPU files. That means all sources must always be available. The compiler can use JavaScript classes through external class definitions. All classes available in the JavaScript runtime and in the browser are available through import units. This is comparable to the Windows or Unix for the native compiler. For Node.js, there is basic support for the Node.js runtime environment available, and an import unit for jQuery is available. libjQuery it's called. As a non-commercial open source project, we are always searching for helping hands, so if you want to lend a helping hand, https wiki free Pascal org paz2js how to contribute. The website of the FPC Lazarus Foundation is being rewritten in paz2js and will be the working example of an in Pascal coded website compiled with WebAssembly and paz2js. We have 2 extras added to serve our community even more. Visual Studio Code is now supported by Lazarus. The explanatory article is published in the Blazed Pascal magazine. Second, Delphi Code can be handled by Lazarus and can be recompiled with the Delphi compiler. This means you can code in Delphi, open your code in Lazarus, and alter the things you want to change. You can now work under Linux, but also compile for Linux, or do the same for the Mac. Once done, you can recompile all of it with the Delphi compiler. 1. WebAssembly for Free Pascal and paz2js. WebAssembly, WASM, is a binary instruction format for a stack-based virtual machine. That means a stack machine is a virtual machine in which the primary interaction is moving short-lived temporary values to and from a push-down stack. WASM is designed as a portable compilation target for programming languages. It enables deployment on the web for client and server applications. WebAssembly is designed to maintain the versionless, feature-tested, and backwards compatible nature of the web. WebAssembly modules will be able to call into and out of the JavaScript context and access browser functionality through the same web APIs accessible from JavaScript. WebAssembly also supports non-web embeddings. You can define the portable binary format to serve as a compilation target. This can be compiled to execute at native speed by taking advantage of common hardware capabilities available on a wide range of platforms, including mobile or IoT. I'm going to mention some additional features. It is initially focused on key features like threads, multiple data stream. It designs to execute within and integrate with the existing web platform. It also executes and combines with JavaScript. And now it allows synchronous calls to and from JavaScript. You also have access to browser functionality through the web APIs accessible to JavaScript, so you can define a human editable text format convertible to and from the binary format and designed to support non-browser embeddings as well. The next point. Artificial intelligence. TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. It will also be of help in the project for Pascal Learning. The Lazarus PDF Kit is an ongoing project for our Lazarus programming. It originated from a text search engine, finding a text in PDF files. Because of the search capabilities, it will be used in the help file, F1, in Lazarus. It will gradually be extended with all the needed functions one has in a PDF, and Michael puts extra efforts into it to create maximum qualities, so we will finally have a PDF kit that has very high standards, especially for the graphical display. It will be usable on all platforms and free, available for any user. We choose the name Lazarus PDF Kit. The Lazarus Learning Project is a project for Lazarus for beginners and for kids. Now about Fresnel. Fresnel is a visual component library. It is based on CSS and custom-drawn components. It is in an early stage of development, but we have a first proof of concept. It is an alternative for the LCL. and that is capable to have pluggable rendering engines like Skia. Skia is an open source 2D graphics library. It provides common APIs who work across a variety of hardware and software platforms. It serves as the graphics engine for Google Chrome, Chrome OS and Android. And it is a replacement for the LCL, the Lazarus component library. The LCL, Delphi counterpart VCL, is old. The foundations of this UI framework were laid 20 years ago when it was conceived as a free version of the VCL, which is the framework used in Delphi. Its design reflects the Windows User Interface Toolkit, Windows 95, the Windows 32 API available for the first time in Windows 95. You could say that the LCL is a 7-year-old technology. You can take 20-year-old code and still create a working application today, thanks to the great efforts to keep things backwards compatible. Very important. The user interface development in the browser is based on two standards: HTML, the DOM, and CSS. CSS offers a lot of possibilities in terms of user interface customization, and the possibilities of CSS still grow. In response to these new platforms, FireMonkey was introduced in Delphi, an alternative to the VCL which can be used on multiple platforms. It has styles which can be used to accommodate for the various form factors and can be seen as a replacement for CSS. FireMonkey can handle different backends. For example, Skia can be used as a backend for OpenGL. But at its core, FireMonkey still uses the positioning pattern used in the VCL, and the styles mechanism uses a format of resembling the DFM format. Instead of introducing a new format to update the user interface layer of Lazarus, it is a logical choice to reuse a successful and standardized mechanism, CSS. The paradigms of the VCL must be completely thrown overboard. And that means no more obligatory positioning, no more properties like top, left, width and height. Instead, all matters for the UI, user interface, and layout must be delegated to CSS properties. In short, the aim of Project Fresnel is to make a set of controls or widgets which are guided by CSS. These controls obey the following architectural principles. The widgets must be streamable. That means the widgets are descendants of the component and must use published properties. This requirement means a form file can be made, and the Lazarus IDE can be used to manipulate the widgets. The layout and looks are determined completely by CSS. This means every widget has a property which represents the CSS to be used. This means every widget has a property which represents the CSS to be used. Additional properties for manipulation in an object inspector can of course be introduced. Multiple drawing backends must be supported. Since Lazarus is multi-platform, it goes without saying that the various platforms will provide a specialized backend, much as the custom-drawn widget set of the FPGA-based widget set offers today. The FPGA means Free Pascal user interface. The widgets will be independent of this LCL. No dependency on the LCL must exist. The widgets must be able to coexist together with an LCL framework. An application must be able to handle LCL forms together with CSS-based forms. In effect, the LCL will provide one of the possible backends for the Fresnel widgets. Ideally, a project made with Fresnel widgets should be able to take an existing CSS framework, such as Bootstrap, Foundation or Tailwind CSS, and apply it to a form. That means we need to provide several things: a CSS parser and a mechanism to translate the CSS to native structures, a CSS resolver mechanism. This mechanism determines what the CSS rules apply to a given widget, a drawing mechanism that knows all supported CSS properties, and a layouter. CSS has several means to determine the layout: float, flex, grid, etc., as determined by the display CSS property. Some widgets that mimic the standard HTML elements. The CSS framework assumes the existence of certain tag names like div, span, p, label, etc. So we need to provide widgets that react to these names. The work on this has been started. A CSS parser and resolver have been created already. A drawing backend based on the LCL has been started and the first layouter has been written. A CSS rule can select elements based on tag names, elements, IDs, pseudo-attributes and tag hierarchies. For object IDs, it seems natural to use the component name as the attribute. This removes the need for the HTML equivalent of getElementById, since every element will be a component defined in the form. A tag hierarchy maps naturally on a parent-child relation such as it exists in the VCL or LCL. The mapping between tag names and attributes has been abstracted in an interface. It is up to the widget what tags and attributes it reports to the CSS engine. Project Fresnel is a large project to rejuvenate the user interface possibilities of Pascal. The project has been started already and the first results have been obtained. A proof of concept using the LCL as a backend has been created. The code can be found at Git repository on GitLab. Matthias, are you there?
I'm there. Can you hear me?
Yes, I can hear you very well. I hope I explained enough so you can start. Please take over.
Okay, thank you. Wow, this was a lot of information, I guess. So I guess there are a lot of questions, or maybe so many questions that you don't know where to start asking. So let's see. Share something can share. Let's see. So let's start with Fresnel. Yeah, as that I've already told you, Fresnel is a new paradigm. So it started with the usual, as you know, you have some units, you have some components, and some forms, Fresnel forms. So this is the same as you know it from the VCL. You have some forms and an application. And with the Fresnel, you have a Fresnel form, and you have some components that you can drop onto it. And here I have some example. So what we have today, this is a proof of concept. So rudimentary. We have some components, we have some classes. As you can see, we have at the moment tbody, tdiff, label, span. And you can drop it already in Lazarus in the form designer. So you can just create a Fresnel form. And at the moment, this Fresnel form is an LCL. This was the SL backend, so this is an LCL form behind. And that's why it works in Designer. But the actual Fresnel component is not an LCL. So the Lazarus IDE is capable of representing and designing all kinds of T components. So it does not need to have to be LCL. So what you can see, this Fresnel form is actually, as you can see, if I go down, you can see it's going to Fresnel viewpoint and a Fresnel element. Element, we just choose the name because it's also similar to the CSS. And you can see it goes down to T component. So there's no LCL in between. So a Fresnel application and the Fresnel forms are just all only Fresnel, staying in the Fresnel universe. And then you have some LCL backend. And that's why it's shown when I will run it. What the IDE needs just a decomponent. It can read it, it can write it, it can create all kinds. So this is just a feature of Lazarus, and was also was needed to extend the Lazarus IDE. As you can see, you have this T label. So if you're looking here for T label, then you can see it has a T label and it shows in brackets Fresnel controls. So you have actually in the IDE, can you now register duplicate label. So a T label for LCL and a T label of Fresnel. And the IDE is clever enough to spot which one is used. So, and if you then look up, if you know some LFM code, and you can see it just looks the same. It's the same format, the LFM, and that's why the Lazarus IDE can work. So what you can do with the Fresnel. Fresnel is, as yes, that I've already told you, it's based on CSS. So the CSS, we have a CSS parser and resolver, which can parse and attributes. We have at the moment about 50 attributes that are supported in Fresnel. So you can basically position and colorize and set some borders, margin patterns. And and then so you decided you put the components onto the form. You can also create, of course, via code, or you can read it otherwise. So it's planned to just use some HTML importer. So you have some HTML, and then you can import this from there. So you can put some components onto it, which I already done here. Put some components. Well, not placed a new label. That's okay. Inside the div. And and you see the T label doesn't have many properties. It has its caption. I'm not sure if you can read it, a little bit brown here. It has, of course, the classes, just like an HTML element. You can define some classes which are used in the CSS. The name is just a component name, which you can use to identify it, and it's of course a Pascal name. So you have still this nice design and Pascal combination in the IDE. And each element. Well, let's start first with the style sheet. Form sketch and CSS class. Where's my style sheet? There's my style sheet. Oh, that's a little bit small here. Okay. So if you're not sure if you can read it on the big projected area. We have a rudimentary CSS style sheet editor. And as you can see, we have I've just added a simple CSS chart as a div. And you can see for div, I defined in the CSS some padding, 2 pixel border, 3 pixel margin, 6 pixels. So if you're familiar with HTML and CSS, this is completely standard. And we're trying to using all the attributes in the same way as known in HTML. CSS is not only for HTML, it's also for SVG or for MathML and other languages. So CSS itself has a basic structure, but it has several applications. And Fresnel is just another one, but it's pretty similar, and the attributes are the same. So that's why I have defined with the style sheet for all this, the padding, border, and margin. And this is what you actually can see on this. So these, the blue and the red, these are all divs. And then you see this div, well, you can't really see it. It's a little bit it's transparent. As you can see, this is a div 2. And yeah, and each element, of course, has its inline style, similar to the HTML element. So you can define what each element is. So this is, as you can see, this has position is absolute. So it is freely movable on the screen, on the viewport inside the window. And just provided some left top width height and the border color black. So this is so each element has can have some CSS element, a style sheet. Then it has the form has a style sheet, and we plan to have an application-wide style sheet, or maybe multiple. I mean, for the CSS engines, it does not matter how many style sheets there are and how many styles, but we will see. This is all proof of concept, so it's not yet decided how it will work in the end. But the engine at the moment is completely free for that, so it's very flexible. Yeah, so you can. So and the idea is you have some an LCL application. Maybe you have some that you have for many years working, and now you maybe want to go to the want to use something new. The advantages of or let's say the limits of the LCL is all pixel based. So on bigger screens, especially on mobile devices, you have often a scale factor. So it's not just scaled to a different resolution, but you also have to scale it. So, for instance, all the line widths and pen widths. So if you have some lines, you have very high resolution screens, and then if you want to paint just a line, it has to be not just 1 pixel in width. It has to be don't know. I think there are now devices up to 7 of scaling factor. And that's why you need some floating point. So we are using doubles for all the pixel coordinations and coordinates and all the painting, similar to CSS, JavaScript, and HTML. So in the browser. So this is was missing in the LCL. Also some better kind of handling of alpha. And some paths and everything, and net SVGs and and some and some GPU accelerated optimized rendering. This is actually done with the LCL. It uses native on all operating system. The LCL uses already the native underlying rendering systems, so it has already GPU optimized uses always. So if you are moving some bitmap or painting something, that's already using the optimized version of the operating system. Yeah, but what was missing was with the elements, with the components itself, the positioning, and you need some fractions, and that's why we definitely need some doubles. So. And you want to have some CSS. So you have a style sheet. You can use the same style sheet across all operating system, or you can provide a style sheet for each of your target hosts. For example, for Windows or Linux or Mac, some different ones. And this flexibility you get with CSS. And also with different with mobile screens, if you have different resolutions, all this you get for free in CSS. Well, not for free, but yeah, we basically have the CSS engine. So the next step is we have if you have an LCL application and you want to migrate to Fresnel. The idea is that you don't have to, like in transfer from VCL to FireMonkey, that you have to rewrite your whole program. Instead, as you can see, what we have seen, this is a Fresnel form, but the actual main form here, this is an LCL application with an LCL main unit, an LCL main form. So this is just the normal LCL form, LCL button, and I could have also used the Fresnel form. Yeah. So you have this, and you can see I just have a button. I can click on it, and then it will show a Fresnel form, and it will show. So you can mix up Fresnel forms and LCL forms in one LCL application. So you can migrate one form by one form. So each form can be migrated one at a time from an LCL form to a Fresnel form. So and you don't have to go everything in one time piece. This is what's stopping most program projects to migrate to a new system. So our idea is to you can migrate form by form. So, um, yeah, what you have to do is to support more attributes, to support more layouts. At the moment, we have basically a flow layout. As Detlef already told you, HTML and CSS have more layouts. We want to support the modern one. So the basic is the flow layout, the grid layout, the flex layout. So these three we are planning to support. And then once we have the basics of these basic attributes, like scrolling and all kinds of attributes, animation attributes, and then we want to support more and more components. So the basic components, as you can see, div, body, label, span, they are there. You can already create a button based on that. With just, for example, a div, and then you create some border, nice colors, and then some events, and then you basically have a button. So this is how it's working in HTML, and the same it's working in and will be working in Fresnel. And then the next part is the backends. At the moment, as you can see, we have the LCL backend. It's a little bit rudimentary, but it works. But of course, it's pixel based, so you can't have now at the moment the full capability of Fresnel and the CSS. But same as so we need a rendering engine that works cross-platform in the same way, and that's why one idea is to use Skia. Skia is, as Detlef told you, is an 2D rendering graphic engine used by Chrome, but also by Firefox and Mozilla and Thunderbird. So it's very well maintained. It's open source, BSD license, so very open to use. And there is a project, Skia for Delphi, and Skia for Delphi, and Skia for Delphi. They because Skia is written in C++, you need a nice layer in between to access it from Pascal. And the Skia for Delphi project, they already did it for Delphi. And I ported, I extended the Skia for Delphi to use it with the Free Pascal compiler. And you need the newest Free Pascal compiler for that. Because due to some anonymous functions and generics. And so it's compiled with Free Pascal, and it's it already works on. I've tested on Windows, Linux, and Mac. It works with Free Pascal, and I've already started an LCL control with it, so you can see. So I have this. Okay, so this is just an LCL application. This is an LCL form, an empty form. But this here, and the form create. I created a SKey paint box. This is a Skia paint box, LCL style. And you can see I've set the on draw event, and I'm loading a PNG file, an image file. As you can see, this is just memory stream, load from file, position, load. And then I can Skia image make from encoded stream. Yeah, and then in the paint, on the draw function, I already tried and tested a few capabilities of Skia. Skia is, it comes with just one dynamic library. So it's a DLL on Windows, it's an SO file on Linux, and a dynlib file on Mac. This is a Mac. And can just show you, or yeah, let's start it. Oh. Huh? Probably something to debugger. Maybe I've confused it. So, so I can start without a debugger. Then it's as you can see, I've so this is already an LCL control using Skia, and just painted a few basic things. Load an image. Image can I also paint, as you can see here. Some text just to show some this text is already working. This is already antialized, so it's you can use this in LCL with activating antialiasing, which is already default on Linux and on Mac. But on Windows, of course, it's antialiasing is not built in LCL, so you have to use some component. You have to draw it yourself. And there are some slight differences how fonts are rendered, and how this antialiased paintings differ on each platform, because on Linux you're using Cairo, and on the GTK is using Cairo. If you're using Qt, you're using Qt. On Mac we are using Cocoa, which is a Quartz engine, and on Windows, of course, you have the Win API. And that's why there are several small differences. And when we are using Skia, we know this is working on all platforms the same. And Skia has various backends itself. So it's for various GPU. So it can use the GPU. It can use, for example, from OpenGL, Metal, Vulkan, a lot of different backends. We have to see which one we will use on the various platforms. So this is Skia already working, and this I've tested this on Linux and Mac. Probably it also works on Windows. So we have already Skia on Lazarus LCL components. And the next goal and next step is then to create a Skia application without LCL, but using, of course, the Fresnel component. So if you have migrated your LCL application, or you have written a new Fresnel application, you have started with an LCL application, your old application, and then you have migrated each form one by one to Fresnel. And once you have done that, the idea is then you should be easy to go completely to a new Fresnel application, and then using Skia as rendering. And yeah, basically what the LCL is doing with to creating windows and handling the events. The same or similar will be done for Fresnel.